This is the solution of the previous activity where you have to take a photo every 2 seconds on the Raspberry Pi and then send the photo when you request it, either from Telegram or from the Arduino. And let's start with this Arduino code actually. And well, this code we've already done that multiple times, so I'm gonna open activity number 6, for example. And on the activity number 6, I have the code to read from the push button. I'm just gonna copy this and put that here. And I'm just gonna remove what I don't need. So we were using the servo motor, but I'm not going to use servo here, just the push button. So I'm gonna remove that. I'm gonna keep the serial, of course, with this baud rate, and then I'm gonna remove this part. So as you can see, with serial, the code that we did is quite modulable. Okay, we can just take some parts, remove some other parts, and it's quite easy. And now, well, we have the complete code to read from the push button and send button pressed when the button has been pressed with the debounce mechanism. Okay, I am gonna upload this to the Arduino directly. Activity 9. Let's upload. And well, can't open, well, my Arduino is not plugged to a Raspberry Pi, so that's not gonna work. You can see now, okay, that's something very interesting. This time I don't have TTY ACM0, I have TTY ACM1. Okay, let's try to disconnect again and to connect back. Let's see again what we have. And we still have ACM1. So I'm going to use ACM1, and that's something to know when we try to connect from the Raspberry Pi, okay? So upload, done uploading. Let's just check that if I press on the push button, I get button pressed. That's correct. Now let's go to the Raspberry Pi side. So we need to do a few things. We need to read the serial to get the push button notification. We need to take a photo every 2 seconds. And we need to also send it to Telegram and receive callbacks from Telegram. Let's do the first thing here, maybe to take a photo every 2 seconds. I'm gonna remove that. Okay, let's import. So from Pi camera, import Pi camera like this, and then let's create a camera. So camera is equal to Pi camera. Let's put the settings directly. Camera dot resolution, and I'm going to use a quite small one because, well, we don't need more actually for what we want to do. And camera dot rotation is equal to 180 because I have seen before that the images I take are upside down. So check that for yourself before, and then maybe use the camera.rotation setting. Let's add an image folder name, which is /home /pi/camera. Okay, let's actually go in the file manager and see. We have the camera folder here already with new image and new image 2. Well, let's keep this like that. So the folder exists, but I'm just gonna make sure it exists just in case, okay, if you remove it later on and if you try to run this program again. So let's import os if os.path.exist with image folder name. Actually, if it doesn't exist, we do os.mkdir with the folder name. Okay, that's very quick to do. And now we have the folder, and let's do image file name is equal to image folder name plus slash, let's just call it photo.jpg. Okay, so every time we're gonna take a photo here, we're gonna replace the previous one. Then we need a time.sleep 2. Actually, maybe if I close this string, it's gonna be better. And we need the time.slip2 to allow the camera to adjust to the luminosity. And then, well, let's take a photo every 2 seconds. So let's do while true. Let's do camera dot capture with image file name. And well, I'm not gonna use time.slip2 here. Why? Well, I could use that actually just to take a photo every 2 seconds, but then as we are going to need to read from serial, I need to do a non-blocking slip. So I'm gonna add here last time photo taken equal to, and let's import time.time, and let's say photo delay is equal to 2 seconds. And so now what I'm gonna do, I'm not gonna add a time.slip2, but I'm still gonna add time.slip with 0, 1, which means that we are still going to block a bit, but basically just 10 milliseconds. Okay, so we don't use too much CPU, and that's gonna be completely fine for the rest. And then we do if time dot, so let's actually create a time now variable with time.time. So if time now minus last time photo taken greater or equal than the photo delay, okay, already done that before, then we do last time photo taken is equal to time now, and we take the photo. All right, let's just try this part of the code. Let's run this. So we don't have any communication with serial for now. Activity 9. And we don't have anything printed, of course, so we don't have any output. But let's go to our folder here, camera. We have photo. That's one photo, and let's wait 2 seconds, and let's click on this. Okay, let's open it. Well, we have a problem here. Let's just refresh. Okay, we have another photo that was taken. That's different. Okay, same file, it has been rewritten. Maybe you need to just refresh the view on the file manager, and then you have the photo. Great, so this part is working. And now what we need to do, we need to send that to Telegram. So we're gonna first use the way that we can request from Telegram, okay? So for that, I'm gonna go back to activity 8. I'm just gonna use the code we did before. Okay, so we're gonna import the updater and the command handler. We are going to create an updater, a dispatcher, and then we're gonna add some handlers and start polling. I'm gonna copy all of that. And where do we put it? Well, let's just put that after we have initialized the camera and after the time.slip. So we open the file with the bot, Telegram bot token. We create an updater, we create a dispatcher, and then we have some command handler. I'm gonna remove that. And I'm just gonna put start, and we want get photo, and I'm just gonna put get photo. So we have a start handler and a get photo handler. Let's create those handlers here. Actually, the start handler is gonna be the same as before. Let's just put welcome. And let's create the get photo handler with update context. And so what we need to do is we need to retrieve the photo that was taken, and we need to send it with bot.sendPhoto. So let's do with open, and that's going to be image file name. Okay, we already have it. And with rb as, so let's say as photo then we do context.bot.send photo with chat ID is equal to, let's just reply to the update.effective chat.id, so whoever is triggering the bot, and then we don't have text, but we have photo is equal to photo. All right, this seems okay. Let's actually add a print here. Print camera, okay. And maybe add here print sending photo to Telegram. And one other thing is we need to stop the updater, so I'm gonna add a try here with the keyboard interrupt exception, except keyboard interrupt, and we do, let's do print stopping Telegram updater and updater dot stop. Okay, let's try this. So I'm gonna run. We have camera okay, so it's gonna take photo every 2 seconds. And let's go to Telegram. Let's do /get photo, sending photo to Telegram, you can see here. And we received the photo. So may take some time, depends on your internet connection speed also, and well, different things, but you can see we have the photo. If I do start also, I have the start message, welcome. Okay, if I do get photo again, okay, you can see here we have an error. Well, because probably we are just requesting the photo when it has been updated. Okay, so let's try again. Okay, and now it's working with a different photo. And so, well, you can see it's working. Maybe an improvement could be that you make sure that the file can be opened, because, well, if you actually take a photo and update the file and try to send the file at the same time, that's not gonna work. So that could be an improvement you could do, or maybe try to use a different file name for each photo. Okay, so I leave that up to you as an improvement of this activity. And then, well, we still need to do something else here, is that when we have pressed on the button, we need to send the photo as well. So I'm gonna initialize the serial communication, and I'm gonna just take from activity 8, just gonna take this code, and let's put it here. So we initialize the camera. Let's just put the serial code here. So first we connect to serial, and then we're gonna put that here, maybe after the camera. So we initialize serial, we initialize the camera, and then we give some time for both to be set up. And here I don't need to do sleep 2 and 3, that's gonna be 5. I just keep 3 for both of them, that's gonna be okay. And I just print camera okay here, serial okay here, and I reset the input buffer. Okay, so everything is correctly set up. First serial, then camera, and I am going to, before I forget, I'm going to close here, print closing serial, and I'm going to do ser.close, okay, so we don't forget. And then I'm going to read here from serial. So we have this action, which is to take photo, and I'm gonna add another action, which can be after or before, it doesn't matter, read from serial. So if ser.in waiting is greater than 0, we do messages is equal to ser.readline.decode UTF-8 and rstrip, and then we check if message is equal to button. Let's check this again, button pressed. If this is button pressed, what we do is we send the message. So to send the message to Telegram, so we send the photo actually. To send the photo to Telegram, we need to add a bot. So I'm gonna add from Telegram import bot object, and let's go where we initialize Telegram. Here we have an updater. I'm gonna create bot here is equal to bot with the token, with the same token. So we have both a bot and an updater. Now we can use this bot to do bot.send photo chat ID. So what is the chat ID? Here we don't respond. Okay, we don't respond to a message where we have the update with the effective chat ID. So we need to know what is the chat ID of where we want to send. And so I'm gonna just use the chat ID. So that was here in the activity 7 chat ID. I'm just gonna use the one that we found previously. So let's put it there, chat ID. And so I do chat ID is equal to chat ID. And then, well, I need to also open the photo. So I'm gonna do this. Actually, I'm gonna do this. So I'm gonna do with. Let's put the correct indentation. So when the button is pressed, we open the image file name as a photo, and then we send photo is equal to photo. We send the photo to the chat ID, so to the chat here, to the group chat, the same way we send it when we request with the get photo comment. So now let's run that code again. Okay, we have an error here. Serial is not defined here at the beginning. Well, actually, this is the problem of when you take some code from other programs, is that maybe you forget to take everything. So import serial, that's gonna be better like this. Okay, could not connect to serial. Well, because actually I have to put 1, okay, because if you remember here I have TTY-ACM1, so it's important you check the serial before. So I'm gonna use TTY-ACM1 here, run the script, successfully connected to serial, camera okay, serial okay. So it's taking a photo every 2 seconds. Let's open the Telegram app and let's press on the push button, sending photo to Telegram, and you can see we receive a new photo. Well, that is me pressing on the push button. And if I do /get photo, I can also get a photo. So here we can see that this is not the right timing. Let's try again. And we get a new photo. All right, so in this program, you have mixed. So on the Python program on the Raspberry Pi, you have used serial communication with the camera, with the Telegram bot. And now you can mix Raspberry Pi functionalities and Arduino functionalities in a more complex program. And this is perfect because we are just about to start the final project of this course.